Welcome, everyone, to Excode Week 3. Congratulations to everyone for making it that far. So the topic of this week is finding structure. Should have been easier. Yes, perfect. So finding structure. We know how messy the student's life can be, so that's what we're bringing in from the computer science perspective. Before we start, a couple of administrative points. First of all, congratulations. You already made 3 weeks out of the 6 weeks journey. As a reminder, there will be no Excode next week as we have a post reading week. We will all send you a recap video so that you can review the previous concepts on your own time. And if you haven't finished any workshop, you're really open to continue and working on those. And we're starting again with week 4 on the 4th of November, then week 5. Then week 6, there will be a post for exam week, so you have your time with your exam. Then week 7 is celebration. We'll have really nice certificates. We have the founder and head of Tech Southwest coming here and giving a talk about the future of coding and how students can leverage the Southwest and the UK initiatives to learn coding and entrepreneurship and related things. Additionally, we're also going to have a coding competition, which is going to be announced on week 4 when we come back. So stay tuned for that. And we also have a collaboration with the Financial Society after Excode, so after week 7. Also stay tuned for that. We'll announce everything in week 4, so in 2 weeks. So say that, let's start with the content. This week, we're going to study the following 3 concepts. First of all, data structures, which are a fundamental milestone in any programming language. And then 2 examples of data structures, lists and dictionaries. We also, as always, going to give you sample programs to kind of see how those concepts apply in the real world. And this week, we also have an amazing speaker that will talk about his coding experience. So let's get started. Data structures. Last week, we studied variables. Do you remember the base definition of a variable, what a variable is? We're good at that? So variable is a box inside of a computer. And some of you really like the example of the box. So we've got a lot of boxes. So let's get them here online. I hope you can see me. I'm going to play with these boxes. Why? Because what we've seen last week is working with a single variable, a single box. And in real life, more often than not, in a lot of applications, you'll need more. And maybe a lot of boxes. And that's where we have data structures. So data structures are a way of structuring data in order to make it easier for us to store and manage all of those. So whereas a variable is a single box, data structures are multiple boxes organized in various ways. And so the solution to this problem, data structures. And the first one, the simplest possible, is called the list. The list is the simple possible thing. And we're going to look at it, first of all, from a physical perspective, and then bring it up into the programming realm. So what a list is, it's a shelf, the most basic way to organize things. So if you're going to a library, you're going to have plenty of books, plenty of things. How they're stored is on a shelf. And on the shelf, every single item is a variable. So this is our list, our shelf, and it is the first variable here, the second variable, the third variable, and the fourth variable. And this makes it really easy for us to work with data because we know kind of the order. We know if I want the first one, I need that one. If I want this one, I can get that one. We're going to see an example of this. The only difference between just a list of variables and how actually list works is that rather than having a separate name for every item, which makes it a bit clunky and weird, we just have a name for the list, and then we have a way to represent it through a number. So the way it works is, you can see here, every single one of these boxes will have its own separate value. We're going to give an example just after this. But the way we count them is with a number. In programming, we start counting from 0. Unfortunately for some of you, but on the long run, it pays off. But at the start, it means you need to get used to it. So what does that mean is that if you get this one, this item here, it will be the 0th item. Let's try. If I get this item, what will be its index? 2, correct. Because 0, 1, 2, 3. That's how we count in programming. Go on, good catch. So you may have a lot of errors in the workshop due to this. No worries, there's the workshop leaders for you to help. But the idea is that it is really simple, once I know that I need to start counting from 0, to organize my items in this list. And we can look at an example. So if I want a list of the prime number, I'm going to call it primes, and I'm going to have 2 is the first item at index 0. 3 is the second item as index 1. So we'll be like saying, in here, I put the number 2, which is the first prime number. In here, I put the number 3, which is the second prime number at index 1. So this is how I'm storing the information in a base data structure, the list, like a shelf. And here you can see how it works in programming. So we have the name, as always, the equal sign. List is a bit similar to a variable. It's a collection of those. Additionally, if you remember correctly, the good thing about Python is it's easy. One symbol, one thing. Comments, hashtags. Strings, quotation marks. List, brackets, square brackets. Simple. So if you see a square bracket, what do you think? List. Great. So what happens here is that I'm doing exactly this. So I'm creating the list. I'm like setting up the table, and putting all the items in it. So I'm putting a 2, I'm putting a 3, I'm putting a 5, I'm putting a 7. And then I can do the same thing with strings as well. So this is a similar list of strings. So the first item will be Ada Lovelace, and that's the first item on our list. The second item here will be Alan Turing. As another example, we can have plenty. We can also have mixed data types inside of lists. So this is a text, this is a number, this is a Boolean, for instance, which we saw last week. And the fundamental way of doing it is the name equal square bracket, item 1, comma, item 2, comma, and then you can go as long as you want. So you can keep this for future reference. When you create a list, you remember, obviously you don't have to remember it by heart. You can just go and check the lecture notes. Everything is on the lecture notes, as always. We have plenty of ways of working with lists. We're not going to go over all of them. This is more of a cheat sheet for you to keep. We're going to cover maybe the 3 or 4 main ones. So let's start, and let's do a blank state. So we have nothing. All of these are obviously in the lecture notes as well in terms of code. So the first thing is I create my list. So I take the shelf, and I put 2 items on here. Let's say the first 2 primes, 2 and 3. Then I realize I want to add another item. So what I do is I do list.add, add brackets, and then I can say, and then add it. I can also use insert and say where I want to insert it. So if I take the number 5, I say list.add, and I add it. That's an example. Then I can remove. I can go list.pop, which removes the last item. So list.pop, removed. Or I can do other things. So another thing I can do is list.reverse, which reverses the order. So this one goes here, and this one goes here. So this is how we're working. These are examples. We're going to see them. And to look at also sample programming, we're going to look at an Italian chef, or something like this, with a computer, and see how an Italian chef and also developer could manage his restaurant through lists. So let's look at that example now. So as a recap, all the points we've covered are here on the lecture notes, such as creating a list, then printing it. We can see here the list is empty. Then printing the type, so it's a list. And then you can give example like a list of strings. And when you print it and put the name, it is going to print the list. It is quite intuitive. It's similar to how variables worked. And you can have list of numbers. You can have list of strings. You can have mixed lists as well. These are all things you can look at while you do the workshop. So now let's look at the working with lists. So we create the list of numbers, 0, 1, 2, 3, 4, 5. This way it's as simple as possible. So I create it, and I print it 0, 1, 2, 3, 4, 5. And then if I want to print the first number, I go print number square brackets. Remember, square brackets are lists. So this is the index, and here I get 0 because 0 is the first item here. If I do print numbers 1, I'm going to get 1 because here is the index of the thing inside of the list. And I can continue these other examples. Then adding, I go dot append, and then I give here the number, or removing, primes.remove, or removing by index as well, or the last element. These are all things you can look at. We've looked from the lecture from a more theoretical perspective, and then the code, when you're in the workshop, you can go and literally copy or look at it, how syntactical everything works. Theoretically, is always the same. To create, you do the equal and then the square brackets. Then to do actions, you do dot, and then the name of the action, such as name of the list dot remove, name of the list dot pop, name of the list dot insert, name of the list dot clear to clear it up. And there's other things we can do with lists as well, such as adding to lists with the plus sign, reversing a list, as we just saw with dot reverse, or others that I leave to, obviously, the reader. So let's look at this Italian chef restaurant. I'm starting, and I need a menu. So I'm going to run this, and I'm saying I have pizza, pasta, and healthy salad. And then I print with string concatenation. We've seen string concatenation last week, where we want to take a variable and a string. I use a plus, and I need to convert the list to a string in order to display it. So what happens here, I'm printing initial menu, 2 points, and then string menu. So I see initial menu, pizza, pasta, and healthy salads. But let's say, unfortunately, the pasta ends. So I need to remove the salad, take it out of the list. So I'm going to go menu does remove pasta, and then if I print new menu and then I take the same variable name, I get pizza and a healthy salad because the pasta is gone. We've removed it. But now let's say there's a lot of backlash. People really like the pasta, so the chef needs to add a new thing to it because there's only 2 things now. So I'm going to add tiramisu, so I'm going to go menu.append tiramisu, and you can recognize this as string because of the quotation marks. And when I run this, I get the tiramisu added. Here, with append, it's added at the end. There's ways to add it in other places as well. And then, if I want to add something at a specific place, like change it, I'm going to say menu 1 is equal to vegan salad. So what is happening here is taking the 1, so this means is the second element. So we have here pizza is the 0, healthy salad is the 1. So when I go menu 1 equals to vegan salad, I'm changing the healthy to vegan. So when I run this, I get pizza, vegan salad, and tiramisu. And we can also then print things such as the length of the list, the first item here, the second, because index of 1, and then just print if something is in the menu. These are all examples. You can also leave to the reader. I think here it's missing an str. Even when we do lectures. To show you how everyone has this type of issues, I assure you, even developers will have this type of issues. I'm gonna fix it later. So these are all examples and the way we can work with lists. And last week, if you remember, we also looked at something else that, in terms of conceptually, is really close to list. And it's something called strings. It's something quite simple. We've seen this already. So can someone kind of guess how strings can be conceptually related to list? Do you have an idea in mind? Or it's not that obvious. Yes. Yes, correct. So what I just said is that in a string is a collection of characters. So we can literally see a string, a text, hello, as the same thing as a list of characters. Do you get it conceptually? So it's like saying here, we have our shelf. This is the L, this is the I, this is the N. This, while it's not exactly 100% the same, means that we are much better at working with strings right now. Because we have the 0 is the L, the 0th element, the I is the second element, or index 1. So this means that then all the things we just studied with lists, you can also apply to strings, most of them. You can check with ChatGPT or workshop leaders with the differences if you'd like. But this means that then you can work with strings the same way you would. So add an element in a string. That's why you can put 2 strings together, the same way you can also put 2 lists together and other things. But these are really interesting things conceptually that I think can help you in working with text in general. And here, for instance, you can see when you say name is equal to Linus, under the hood, it's quite similar to having actually a collection of characters. And in the lecture code, there's also a decent amount of code about this. You're free to look at it. As said, I'm not going to cover it now because it's not a core requirement in the introduction section. But if you want to have a look as well, you're really welcome to. Now we're going to talk about multidimensional list. This is where last year we realized that we lost some of you. So this is not an invitation to turn your brain off, but it's an invitation maybe take a second. This is not the most obvious concept. So I'm going to try to make it as simple as possible. But if you need, then feel free to come back to it. We also have just 30 minutes and it's 7 p.m. So we're wary of that. So list, it's one shelf. But when you go in the library, you don't have one shelf. You have a lot of layers. Multidimensional list, that's it. It's one shelf on top of one other shelf. So we can see it in multiple dimensions. Like this. One, then another one, then another one. And we use the same way we use index. So the way we do it is we actually give an index to every row and an index to every column. So as always, we start counting at 0. So first column is the column 0. First item is 0. So if I want to check this item here, the first one is going to be its placement, its index is going to be 0, 0. If I go into this one here, is the second row, so 1. And then it's the fourth element, so 3, thus 1, 3. All clear? So here, for instance, if I say this is the 0th and this is the 1, this item is going to be 0, 1. It's not the clearest, but conceptually, you can see it as a shelf, and then you're really welcome to go and have a look if you have the time. And then if you want really to get your brain fried, you can do it one more time. And one more time. And you can go in a lot of level deeps. If you have complex programming, obviously it's better to not go too much, because then it becomes too confusing and really hard to compute. But on a high level, you could go as many levels deep as you want. And then you can also see it like this. So let's look at an example of a multidimensional list. If I have like football players, Zidane is 0, 0, Platini is 0, 1, Mbappe is 0, 2. And then if I have a new shelf, Neymar is 1, 0, 1, 1, and 2, 0. That's how it works. And you can do basically whatever you do with lists with multidimensional list. You can remove an entire list, add an item in a list, add a new list in the multidimensional list. That's why I say it can get quite, I don't know if you've seen Inception. We're doing Inception, but in programming here. That's a bit how it works, but it can be quite useful. I mean, if you have any experience with the concept of vectors, that's, for instance, lists can be used to represent vectors, or if you go in robotics, when you have to simulate like robot movement, you'll have the 3 dimensions, and that's how you'll have probably a multi-dimensional list to represent all the position in every dimension. That's examples of applications. It's really powerful. Or even if you, let's say, trading, if you want to store the evolution of stock data, you probably have a list or a complex data type to store how the stock evolves over time. That's some of the applications. And then the last topic of today, dictionaries. So we've covered lists, and the idea of a list is to have items on a shelf. The idea of a dictionary is to make it so we can associate each item with a value. So let's say you're storing, you have a password manager, and you're storing all your passwords. If you have it as a list, well, you just have a list of passwords. It's really hard for you to know which passwords is to every website. Do you follow me? If I have password 1 is this, password 2 is this, password 3 is this, I'm lost. So what I do as a dictionary is I assign a key and a value to every item. So I say, the password for Ellie, it's this. The password for Facebook, it's this. My Excode ID, it's this. So this is how a dictionary works. we're associating keys with values. And this is similar to, it's called a dictionary because if you take an actual dictionary and you open it, you'll have a definition, the word, and then the definition. So the first word, first definition, second word, second definition. And this is also another second big and foundational data type, which is not that far from list, but you could say it as a connection. It's like saying, even if you go to the library, you probably will have still the name of the item and then the book. So that will be another way of storing all the books in our library. One way is just shelves with the numbers, and the other way is the name of the books. In a library, you actually have both. You both have the numbers, the numbering system, and you also have the names of every book. So with a name, you can find the book. This is how it works. And this is the foundational idea of dictionaries. Here an example. As always, there's one symbol for dictionaries as well, curly brackets. So I created with the equal, use curly brackets, and then I have the key and then the value. The key and the value can be of multiple data types. Here, the key is a string, and the value is a number. So if I want to store the programming language with the year of creation, and I have Python, then 1991, Java, 1995, and then I can go on like this with still. So you can see how it's not that far from a list. The only difference are the curly brackets and then the 2 points, because you don't have only one item, you actually have two, key and value. And this can be quite powerful in a lot of scenarios. In the lecture code, we also give some examples about how you can do that. So you're very welcome to have a look. So you can start an empty dictionary, and then you can create one. So here you can see how you have the key, the 2 points, the value, and then a comma to separate them up, and then print those. Don't hesitate to ask help from your workshop leaders when you're coding this. The dictionaries in the workshop will not be covered that much. The main thing of this workshop will be around lists as well. You can also see examples on how to work with dictionaries. So obviously the big advantage is that once you have the key, you can find the value. So if you want to store your student's grade, you'll have Alice, A, Bob, B+, and then if I run this, I just print it, so I got my dictionary, and then I can access an element. So given the key, if I print this, I get the value. And I can also do the same thing I did with lists, such as adding an element, modifying an existing element, removing an element, removing all elements, or more advanced things that are left at the discretion of the reader if you want to, but they are not required in the introduction workshop. So we covered the data structures. I will give you a recap of the session, but before that, I would like to welcome a speaker, Rob Sherman. So I've met Rob Sherman last year, and he's been really good in helping me, and he's going to talk about his coding experience.
Can you all hear me? Is that coming through? No. Oh, it's gone green. There we go. Hello. Fantastic. Do I need to get my slides up? Yeah, I'll get them back. Sorry. Thank you. That's okay. I'm really glad to be here. I heard about Lorenzo and I. When did we first speak, Lorenzo? About a year ago. Was it that long? Oh, I'm glad I finally got here. I have a small child, so it's quite hard for me to be out after 6 o'clock. It's also nice to hear that there's a significant minority of humanities students doing this course, representing my faculty. We can't let the scientists and engineers and mathematicians have all the fun with coding. Is that all okay? Great. Okay, fantastic. Thanks so much. Yeah, so just to introduce myself, so I'm actually in the English and Creative Writing department, so this is perhaps a slightly strange place for me to be. My job title is Lecturer in Interactive Storytelling and Digital Cultures. So generally, I'm interested in the ways that digital technology changes the ways that we relate to each other, tell stories, create culture. But I'm actually quite a recent addition to the academic world. Most of my career has been spent as an artist, interactive designer, game designer, and artists working with digital technology. And I ran a consultancy for 5 years called Bonfire Dog. Where are the slides gone? Okay. That's fine. I've worked on projects including app-based projects, virtual reality, video games. Oh, look, my next slide. My slide has been spoiled. That's okay. I mean, I was asked here to talk about the role that code and the active programming has played in my work and my creative process. And maybe Lorenzo was hoping I'd come and share wisdom with you today. But actually, this is the message I want you to take away. I am a chaotic, messy, and downright disgraceful coder. You shouldn't do anything that I do. And part of that is because I'm mostly self-taught. There was no Scratch that we did at school. Did anyone do Scratch or programming, a bit of basic programming at school? There's none of that. IT, when I was at school, was like, this is how to use a printer, good luck to you. But we didn't do any sort of programming at school, as I say. There was also nothing like this when I was an undergraduate 10 or 15 years ago. And my background is a completely humanities-based one. I did an English Lit undergrad. I did a master's in creative writing. So there was no programming on my curriculum at all. But I'd always been interested in computers, in using computers. I knew that something exciting was happening under the hood, behind the keyboard, behind the screen. But I didn't feel that it was for me. You know, that's for people who were good at maths, people who did that sort of thing at school. Someone like me, someone who wrote stories, who worked with the English language, didn't have any reason to explore that. So the introduction, my introduction to coding when it came was much more kind of born of curiosity and accident and experimentation. And there were two ways that I really got introduced to programming. One was through HTML, CSS, so web design. Programmers in the room might say this is a markup language. I would say that it's a programming language. I'll fight you, Lorenzo. Yeah, it's a programming language, but JavaScript certainly is a programming language. So I grew up, or I was in my early pre-teens in the age of GeoCities, MySpace pages, these ancient artifacts that some of you may have heard of. This was before Facebook came along and made everybody's presence on the web look exactly the same as everybody else's. And as I was learning how to make my MySpace page look different or the same to everybody else's, to create my own GeoCities website, I got really excited that my contribution to the web was a way for me to express myself. I could express myself visually in a web browser. That was really intoxicating to me, and it was a really good introduction to what coding could do. As I started to work with interactive technologies, I started to get more interested in how to use coding to realize my ambitions. One of the first professional projects I worked on was a web-based interactive narrative, but I was mostly working with programmers. I was doing the narrative side and the writing. I didn't get to do the programming, but I started to get interested in coding my own stuff. And my introduction to doing that was a tool called Twine. I don't know if anyone's ever used it. It's a really simple way to create your own interactive stories. You basically write passages of text and then use this nice GUI interface to link them together into choice-based stories. It's very, very easy to use. You can go and use it right now, not now, in 10 minutes, at twinery.org. But underneath that very simple GUI is a fully featured coding language. I think it's actually a wrapper for JavaScript called Twee, where you can create more complex effects in your stories. And it was through Twine that I learned about concepts like variables, like data structures, loops, all the things you're learning about on this course. But I wasn't learning it in the abstract. I wasn't just being told, loops are important, this is how you should use them. I wanted to have some effect in my story, and a loop was the way to create it, or I needed to create variables in order to create that effect. So there was an incentive for me to learn how to use these techniques, because it allowed me to do the things that I wanted to do creatively, to tell stories in a particular way. And from there, I've carried on kind of teaching myself and learning and growing my skills in this very messy and chaotic, but ultimately very creatively satisfying way. And I'm going to speak briefly about a project that I did, which I think exemplifies this messy, chaotic, creative way of using coding. and it was actually my PhD project. And the thesis or the problem that I was looking at in my PhD project was, how do you create interactive digital characters that are, how do I put this? Less shit. Like, how do we get better at representing human beings and other characters in interactive stories? And I was interested in ways of doing this that didn't just rely on more code, that went beyond trying to find clever algorithms or data-driven approaches, or this was before kind of big data-based AI. I was looking at more kind of creative ways to do this. And there was a thesis element to my PhD, obviously, but what I was doing was a practice-based PhD. So I made an art project to explore this problem. So I built an interactive digital character. So there was this framing narrative. The conceit was there was this woman in the 18th century who found this demon living in her house, and she co-opted it as this supernatural servant so she could do spells with it and become a witch. And so I built a version of this demon at the Museum for Witchcraft and Magic down in Cornwall, where visitors could visit a live interactive version of this demon and interact with it and even do spells with it. And it was an installation piece. We had props and all sorts of candles. This was a test. This wasn't the final version of it. But in the center of this kind of theatrical installation was a live, real-time simulation of this creature, connected to a range of sensors that would respond to the audience's presence. I coded this by hand. You can actually go and look at the code on GitHub. I don't know how much code it was, but it was an absolute nightmare. I built it using a completely inappropriate tool. It was a tool called Game Maker Studio, which is a game engine for making 2D platformers like Mario, and I used it to create symbolic AI, which is not a good idea. Just huge amounts of code trying to get it to do even basic things. I had no money to employ a programmer. This was before ChatGPT could tell me how things worked in this proprietary coding language. This is code for checking the weather. I haven't looked at this screenshot for a long time. Yeah, this is all code literally just for checking what the time of day is and reflecting it in the simulation. I was also committing a cardinal sin in programming, which is reinventing the wheel and learning how to do something from scratch that somebody else solved in about 1985, and I could have just downloaded a library that did it. So I was, for example, this is a huge amount of, this is a diagram of the kind of code system for tracking the attention of the animal, of the beast, of the demon, like where it's focusing. I spent so long on this, pulled in loads of academic work, built all this in code, and it was never needed. I didn't actually need it because it could only focus on one person at a time, so it didn't need to split its attention. I taught myself how to do fluid dynamics just to make the creature cry. That is not a good use of time. I learned how to predict when the sun would rise just based on mathematics rather than just pulling it in from an API. Also, because this was an engine for making a 2D platformer rather than a piece of AI, I had to hack it to do the things that I wanted it to do. So for example, the installation needed to track where people were in the room. It needed to do facial recognition, speech recognition. But this game engine couldn't do that natively. I couldn't connect it to the cameras. So I had to teach myself C#, build an entire Windows application just to read the data from the cameras and the microphone to pick up facial recognition. This is me checking the emotion recognition. So it was connecting to the Microsoft Azure API and putting that in. It would then write that data to a text file, and then it used the save game functionality from the game engine to detect the text file, read what was in the text file, and get the creature to respond. This is not an ideal way to do this, I should say. Oh, well, it's fine. That was kind of all of the interesting pictures anyway. Oh, there we go. It's just another picture of the beast. So that was about 6 years ago. If that was painful for you to hear about, imagine what it's like for me looking at that now and thinking all the time I wasted doing these things. It would have taken me so much less time. But I don't really regret the experience or the time I spent, because I learned a huge amount, not just about programming at a fundamental level, but about problem solving. It allowed me to apply creativity to technical problems, which I could have solved by just downloading a library, but it really taught me how to think around how to apply technical solutions to creative problems. And actually, these weird approaches that I ended up taking completely changed the way I looked at the central problem in my thesis. So the fact that I had used a game engine that's mostly used for creating 2D worlds to create a character actually led me to the insight that a way to produce characters is not to treat them as characters at all, but as landscapes that the player can explore. And that ended up becoming the central pillar of my thesis. So I think even though I would very much not do anything that I do when it comes to programming, and I would carry on doing Excode, this is a much better way to learn programming. What I hope this shows you is to remember that coding is as much, or can be as much, a creative tool as written English or a paintbrush or anything like that. That it doesn't just have to be used for solving simple technical problems, that you can apply real human creativity to its use. And I would counsel you all to find ways to do that in your work. Not just the humanities students, the scientists and the engineers should have a go at that as well. But thanks, Lorenzo, for having me here. Thanks very much. Thank you, everyone.
Thank you. And that's why in the gaming competition we're going to announce in the next Excode session, there's going to be creativity as one of the elements judged in the game. And you're lucky because you're going to have to code the game in Python, so it's much simpler, and it will be optional as well. So closing in the section, before I give you all the checking code, as a recap, last week we saw variables as a way to store information, and this week we studied data structures. Semantically, the definition is already there. It's a way to store data in a structured manner. We saw two big examples of data structures. The first one is a list. The list is a shelf where you put variables side by side, one at a side. You use an index starting from 0, 1, 2, 3 to count those variables inside of our list, and you can do plenty of things with that list, such as adding things, removing things, or having multi-dimensional lists. On the other side, we also look at dictionaries. Dictionaries are the second big data type, and they store key value pair. What you need to remember is that you have a key and you associate it with a value. So once you get the key, you get the value. Lists are represented through brackets, square brackets, while dictionaries are represented through curly brackets. That is the core of this session. Thank you all. And I'll see you all next week if you want to check in and then go into your workshops. The theme of this week's workshop is about pirate adventure as well, so that's quite interesting. I'm just going to have to check it, actually, because I'm unsure of the code. So it's EX3, and then WR.